Morning, everybody. I am just putting the link to this video on our website now, so give me 2 seconds. There we go, May 5th. Delete the old one. There we go. And publish. Beauty. Good morning. Oops, this isn't the one that I want. This is the one that I want, grade 10. Yeah. That was a fun exit slip from Friday. I really enjoyed reading your plans. It's funny, a lot of your plans were actually similar to what I did too. Some people were saying that they were gonna play a bunch of Minecraft, and I played a bunch of Minecraft with my friend this weekend too. Some people said that they wanted to watch some Netflix shows. I did that too. Some person even said that they were watching Grey's Anatomy, and that's what my wife is watching right now. And I'm really squeamish. I don't like the sight of blood or guts or anything like that. But my wife works in a hospital, so she's pretty desensitized to that sort of thing. So we were watching Grey's Anatomy together. I think it might have been yesterday actually. And I had to stop. I just hit the space bar to pause it, and I was like, I can't go. I'm gonna pass out. It was so gross. I don't even remember what happened. It was just, I don't like seeing blood and needles and stuff like that. And it's funny because my wife used to be the same way when we were first together. She was more squeamish than me, but now that she works in a hospital, she sees that kind of stuff all day, so it's she's very normalized to it. So if you are squeamish and you don't want to be squeamish, I guess there's hope, because I guess they call that sort of thing exposure therapy, where you're just exposed to something that you don't like you have some kind of anxiety or some kind of disposition to not like something, then you can expose yourself enough. And apparently, I guess my wife is a good example of that, because she is totally fine with it. She watches Grey's Anatomy and just all those bloody and gory scenes. She's like, nah, yeah, whatever. I saw that this morning. So, but that also makes me think, why does she want to watch a TV show of a hospital when she's in a hospital all day? Hospitals are not very nice places to be in, right? They're kind of the worst place in the world. They're obviously one of the most important things in the world, especially nowadays. But not a lot of fun. Anyway, yeah, I really enjoyed reading what you guys did over the weekend. It really put a smile on my face. Sounds like a lot of you guys are doing what you're supposed to and taking care of yourself, and that your physical and mental health is doing well, and that makes me so happy. And of course that's obviously not going to be true for everyone. Some people are struggling. I'll be honest, I'm not having the best of times. Sometimes some days are hard. Sometimes days are really hard when we're just kind of cooped up in here. In particular, my physical health is, and it's not like I'm sick or anything or doing very poorly, but I usually ride my bike to work, and that's usually where I get most of my exercise. I so twice a day I get to huff and puff and get some fresh air and pump my legs a little bit. And I don't do that anymore. I've been inside, and I keep telling myself I'll go for a bike ride, and then I never do. So whatever. Anyways, I'm kind of rambling. Just kind of waiting for a few more people to show up, but I think we can start with 7 folks. So yeah, let's just jump right down into it. We're gonna do like this is gonna be our last little investigation with inequalities today. So kind of to put the cherry on top with inequalities is we're gonna look at applications of inequalities. Okay, so that's what we're gonna be focusing on today is applications of inequalities. Inequalities. Oh yeah. I also wanted to just briefly mention the assignment. I have been looking over it. I'm about halfway finished marking it. I'm hoping to finish today. I've been using Google Classroom, and this time I'm hoping to be able to provide some more feedback. So I think I've mentioned this a couple of times, but yeah, this is totally a learning experience for me. So marking everything completely digitally. I think I've got it down, so I've been able to mark things up like with my iPad and everything, and give you check marks and little comments here and there about if you make a mistake, why it's a mistake, and things to look out for. So I've been trying really hard to give you some meaningful feedback on that one. I almost got the impression that maybe the assignment was a little on the easy side. A lot of people getting full marks on it. So so that's good. That's great. I think next assignment I'll try to make it just a little more challenging. Because if a lot of people are getting 100%, it means that there's not a challenge, right? And I need to push you, right? We're learning, so you need to be challenged to truly be learning. So that said, yeah, I hope that I can finish the marking today, and then we can start thinking about another assignment. Okay, so applications of inequalities. This really just means like, okay, we're gonna do like problem solving kind of stuff. We're gonna do word problems, that sort of thing. Okay, so let's just jump into it. I'll just throw a question at you. Okay, so yeah, and again, a couple people asked on the assignment, like, why is there a physics question? I think the last question had the equation E equals 1/2 mv squared, right? Oh, it's physics. That's not math. Well, yes, it is. It is math. Like, physics is just applied math, right? That's what it is. There's a great little comic. I'll put it on the website maybe. There's a great comic about how different areas of science are just an applied version of a different type of science, and mathematics is kind of at the bottom. So everything, all of science is just applied math, really. So that's what we're going to do today. Is we're going to look at sort of real life situations where we'll have to actually use some of these inequalities. So let's just give you a question here, and we'll do this one together, and I'll give you another one, and you can do that one on your own. So let's try this. So the total resistance of 2 electric circuits, the total resistance of 2 electric circuits, I always have difficulty spelling that word for some reason. Circuit. You don't spell it the way it sounds. So it is given by. Okay. R squared minus R plus 1, where R is resistance measured in ohms. Okay, so here's the thing. We do need to know a little bit about electronics here. Not a whole lot, but really, I'll just draw a quick diagram, and I am by no means an expert in electronics. Like I know virtually nothing about electronics, and I'm not just being modest. I really know very little about electronics. But the idea here is that let's say that we have some kind of wire and we have some electricity flowing through the wire, and then you can have a little thing which is called a resistor, and all that does is it resists some of that flow, so that you have like lots of electricity flowing through, and then you have the resistor which is resisting all that electricity, and then you have less electricity flow. Okay, so that's just a really sort of like, that's my understanding of it, and I understand almost nothing about electronics. But the idea here is that we have some kind of resistance, so it's resisting electricity, which means that the resistance must be greater than 0. It's impossible to have negative resistance. If you did have negative resistance, that would be like the opposite of resistance, right? That would be like giving more electricity, and wouldn't that be great if we could give more electricity? That would be free electricity, but we can't. So I guess this would be the circuit here, and the idea is that the circuit is going to convert some of that electricity to, I don't know, like light or whatever the circuit does. So this is the equation of the expression. This is the expression of how much resistance is given by the electric circuit, and R is the resistance measured in ohms. So the whole circuit has this much resistance, and R is the resistance. So when is the resistance more than 7 ohms? Okay, so that's the question. So when is the resistance more than 7 ohms? Okay, so in other words, for which value of R do we get more than 7 ohms? Okay, that's what we're asking here. So let's try tackling this equation here. So I'm just going to copy it out again. So I've got R squared minus R plus 1, and we are asked, when is this greater than 7? Okay, and we are going to remember that resistance cannot be negative, so we do have some restrictions on what our values can be, right? So I am going to, let's see here, well, first I'm going to start off by moving that 7 to the other side. So that'll give me something that looks like this. I've got R squared minus R, and I'm going to subtract 7 from both sides. So we've got minus 7, and what I'm left with is 1 minus 7, which is negative 6, and all of this has to be greater than 0. Okay, so let's go ahead and factor the left-hand side. So if I do that, I'm going to have R minus 3 times R plus 2, and that has to be greater than 0. Okay, so there's a couple ways that we can take a look at this. So I know that when R minus 3 equals 0, or R plus 2 equals 0, that this whole thing, so when R minus 3 equals 0 or R plus 2 equals 0, we have that this inequality is not so much an inequality but is an equality. So we would get an equation that would say r squared, what was it? R squared minus r plus 1 equals 7. Okay? So that's what happens when r minus 3 equals 0 or r plus 2 equals 0. So that would be when r equals positive 3 or r equals negative 2. But right off the hop, we know that resistance cannot be negative. So the only key value that we're concerned with is r equals 3. Okay? So here's what we're going to do. I'm going to make a little number line. I'm going to make a little number line. Right, there it is. There's my number line. And I'm going to have 0 on this number line. Now anything left of 0, this is negative resistance. So I don't care about that negative 0. So, and by the way, these are values of r, right? So r cannot be negative here because r represents resistance and we cannot have negative resistance. So let's see here. I will take a look at the other key value, which is 3. So this is the other key value, 3. So I want to know, is this inequality true on this side or this side? And that's really what we're going for here. So what we're going to do is we're going to take a look at two key values. So we're going to choose any number in this area, and we're going to choose any number in this area, and then we'll see which one satisfies the inequality. So I'm going to choose the value 1 here, because 1 is between 0 and 3, and then we'll see if that value satisfies the inequality. So I'll just take a look at the original inequality. So that is r squared minus r plus 1, and that's supposed to be greater than 7. And when r is equal to 1, we would have 1 squared minus 1 plus 1. Is that greater than 7? I don't think so. So no, that is not true. Because 1 squared minus 1 is 0, so that cancels out. Plus 1 is 7. No, 1 is not greater than 7. So this area right here is not valid. So my guess is that some value in here will work. Let's try the value 4, okay? Because the value 4 is 4 is greater than 3, so it's part of that region. And let's see if this region satisfies that inequality. So I have, I would have 4 squared minus 4 plus 1. Is that greater than 7? Well, 4 squared is 16. 16 minus 4 is 12. 12 plus 1 is definitely greater than 7, right? Because 13 is greater than 7. And I think my head is cutting that off. There you go. So there you have it. So the values for r that we want is r is greater than 3. So in other words, so the final solution is that r squared minus r plus 1 is greater than 7 whenever r is greater than 3. Okay? So, interpreting that into the actual question, we would have that r is greater than 3 ohms. Okay? Just throwing the units in there. Okay? So just to be clear, you don't have to really understand what's going on with electronics. Like I said, I have a very rudimentary understanding of electronics, if you could even call it that. So yeah, you don't really have to understand the science of it, but what we're doing is we're looking at the mathematics of it, and that's actually quite typical for mathematicians. So it's not unusual for a mathematician to be asked to solve some kind of math problem where they don't even understand the context. There is a company called CSEC, and they're kind of like the NSA for Canada. And I remember when I was a university student, they had kind of a recruitment seminar where they told students about what a career at CSEC would look like, and it was really interesting. They said just because of national security, the mathematicians who they have working on their problems in cryptography and stuff like that, the mathematicians are not allowed to know what they're working on. But they are solving a math problem. So they don't know the application of their math problem. They don't know how their solution will be used in the real world. Maybe it's used for some kind of military grade encryption software or something like that. But just due to the nature of the subject, they weren't allowed to know what it is that they're solving. So they're given a math problem, and their job is to sit at home, or not at home actually, at work, to sit at work and to think about this problem and solve it, but they would have no idea what the application is. So the same is true for this. I mean, will you have a greater appreciation for the problem if you understand a little bit about electronics? Yes, absolutely. Do you need to know everything there is to know about electronics to solve this problem? Absolutely not. So just bear that in mind. Okay, let's try another one. This one I want you to try. So here we go. Let me just find it. Here's the problem. Okay, so the height in meters. So the height. Here we go. Zoom in nicely. There we go. Okay, and how about pink? Okay, perfect. So the height in meters of a projectile object, shot from the top of a building, is given by, okay, and here's the equation here. H of t equals negative 16t squared plus 60t plus 25. Where, I'll zoom out when we're finished here so you can copy it all out, where t represents time in seconds after the projectile is in the air. Okay, so that's the situation that we've found ourselves in. So we've got the height in meters of a projectile object shot from the top of a building is given by that blue equation, where t represents time in seconds after the projectile is in the air. Perfect. So we've got two questions here. First question is, find the time the projectile is in the air before hitting the ground. So find the time in seconds okay. Projectile, sorry, I should have been writing this, is in the air before hitting the ground. So basically, how long is this thing in the air, the ground? And question B is find the time interval that the projectile is above 25 meters. So find the time interval that the projectile, I'm covering this with my head, the projectile is above 25 meters. Is above 25 meters. Okay, let me zoom out just a wee bit more. I hope you can still read that. Is that, am I blocking that off? Yeah, you can read that. Okay, so so just to be clear, it's starting off at the top of the building. So here's my building, like that. And the projectile is doing something like this. Right? Something like that. So, there you go. Have at it. My guess is that you'll probably have to use the quadratic formula somewhere. And I'm gonna give you 8 minutes to do this one. Okay, 8 minutes. Oopsies, that's not what I wanted. This is what I wanted. So what did I say? 8 minutes. 8 minutes starting now. Yeah, you should be able to hear me now. Sorry about that. I can see the chat. Yeah, I just muted my mic so that you wouldn't hear me like on my mouse and keyboard while you were working, and I knew I would forget. I can see you. Yeah, I can see the chat now. So okay. So anyways, what I was saying is I do like to yada yada yada. What did I just say? I like to start off by graphing these because it gives you kind of a nice visual representation of what's going on here. So what this represents is that our x-axis is time, right? So I changed it to x because Desmos likes x's and y's. But if we wanted to, we could just say that the x-axis is our t-axis, right? It represents time. So as we go from left to right, you can see that we start off, we're getting bigger and bigger and bigger, and then we start to get smaller, right? Which means that at time 0, we're starting at 25 meters. And you have to say, well, how is that even possible? Because we're shooting it off of a building, right? So at the very first second, right, we're shooting it off of a building. It's going off of a building and then falling back down. Okay, so we want to find the time in seconds the projectile is in the air before hitting the ground. And the way we would do that is we would say, okay, well, when is it equal to 0? Well, there's 2 places where it's equal to 0, right there and right there. The time on the left is just saying, okay, like the negative 0.378. That's just saying, well, this is a quadratic function, so it has 2 roots. Well, in this case, it has 2 roots. But time is not, you can't have negative time, unfortunately. Wouldn't that be nice if you could have negative time? If you could go back in time, a lot of problems would be solved. Imagine that. Can you imagine not having any regret? Wouldn't that be funny? So anyway, yeah, if time could be negative, then we would have this being a point where it hits the ground. But time is not negative. We're only able to go into the future. So, oh, can I use my mouse here? Okay, hold on one second. Oh yeah, now I need my mouse and keyboard again. Ay, what a nightmare. Yikes. Okay, excuse me for one sec. Technical difficulties. There we go. Okay, so yeah, this point right over here, we can't. This point does not make any sense. The only point that makes any sense is this point right over here, which is this root, this root of the quadratic equation. By the way, this is the point where it's at its highest. I don't think we're asked about that though. Okay, so let's head over back over here, and in order to find this, we'd be looking for the roots. And we would use the quadratic formula. Okay, so we would say that A is equal to negative 16, B is equal to 60, and C is equal to 25. Plug it in, and Bob's your uncle. We've only got a couple minutes left, so I'm gonna leave you to that. The answer though is T is equal to 4.128. 4.128. And like that's rounding. So I should say that T, when you round it, right, we put that little dot on top, is 4.128. Okay, so the projectile is in the air for 4.28 seconds. The next one is finding the time interval that the projectile is above 25 meters. Well, what we could do here is, if we wanted to, we could say y equals 25, and we could say, okay, well, yeah, it starts off at 25 meters, right? We already determined that. And where else is it at 25 meters? Well, at 3.75. Okay, so it looks like it's in the air for 3.75 seconds. So that's the answer. So this is part A. Part B, we would have, well, the answer, what did I say, 3.75? Yeah, 3.75. 3.75. But how are we supposed to how are we supposed to get that? Well, what we would do is we would have our equation negative 16t squared plus 60t plus 25, and we would set this equal to 25. Okay, we would set that equal to 25, and then, well, actually, we would say like, when is this greater than or equal to 25? So then we would do this whole thing. We would have negative 16t squared plus 60t. We bring this over to the other side. They cancel out. So when is this greater than 0? Well, we would factor it. We'd factor out a t. I think we could factor out a 2t. We would factor out a 2t, and we would get negative 8t plus 30. I guess we could factor out a 4. Yeah, we would factor out a 4. This would be 15. This would be 4. And this would be 4. Pardon me. So when is this greater than or equal to 0? Well, that would be when t is equal to 0, or t is equal to, what would that be? I guess 3.75. 3.75. Okay. And then just like before, we would have our little number line, right? We would have 0. Obviously, time cannot be negative, so that part we don't have to care about. We would have 3.75, and we would test a point in here or in here, and it turns out that this point is the one that we want. So it's kind of a fast forward version of the solution, but that's kind of a guide. If you got stuck, you can kind of maybe follow a couple of these steps and try to fill in the gaps. So, but the answer is 3.75, I should say, seconds. Okay, and then same with here, seconds. Okay, now is time for your exit slip. Let's see here. I think, oh yeah, I got to change my keyboard back. Here we go. There we go. Okay. Okay, where was that question? Here it is. Let's see here. You know what? We're gonna leave out a math one today. We're just gonna have kind of a fun one. But I am gonna assign some homework. So I guess for the exit slip for the day, exit slip. Okay, so it's not going to be a math-related exit slip. It's just going to be a fun one, but I am going to assign some homework. The homework is going to be on the website, hopefully before noon. So check the website before noon, or I guess if you checked it in the afternoon, then it would be there. So make sure you do that homework. But in the meantime, the exit slip for today is Java, Bedrock, or what is it? Okay, so which one is it? Java, Bedrock, or do you not know what we're talking about? Okay, so which do you prefer, Java or Bedrock, or do you have no idea what we're talking about? Yeah, there's your exit slip for the day. Just something simple. Just let me know if you watched the video. Okay. And yeah, so keep your eye out for the homework. Should be up very shortly, as well as your assignment. Your assignment for the thing that we just finished, which is, I can't believe I don't even remember the topics on it. Was it quadratics? I've been marking it. Sorry, my mind is completely blank. But the last assignment, yeah, keep your eye out for it. I should be finished marking it pretty soon. So, okay, take care, guys. I hope you guys have a good day. I'll show you just one quick shot of Goose. Oh, here, I'll just use the little camera here. She's just taking a little nap. She wants to say hi to you. Real quick. Right, Goose? It's real quick. Okay. Is it? I wonder if this is vertical. Oh yeah, look at her. Just taking a little cat nap in the sun. She loves the sun. She just loves it. Okay, bye guys. Have a good one.